So in this submittal again is going to be 12-foot high basement wall, and the soil is going to be filling all the way to here. So the soil is not going to be here, right? The soil is going to be all the way to this point, and the soil pressure is going to be like this. So this is what you need to develop. The soil pressure, which is Q, this pressure, or P, if you like to call it P, is going to be equal to the given soil pressure multiplied by the height. So it's going to be equal to 60 times 12. And units is going to be pound per square foot. Now this is here simply supported beam, right? You have one support here, one support there. Can you find out the maximum moment? It could be a question to you. Is this possible? Is there like pre-solved moment values that you're going to be able to use to find out the maximum moment at a situation like this? I'm going to consider here, I'm going to assume that you guys have taken statics and structural analysis, at which you have studied simply supported beam with uniform load and with triangular load. So what I want you to do is to look it up online, or maybe look at the steel book. If you guys have the steel book, there's lots of solved like moment and beams. And also you can look it up in any structural analysis book. Just one value here. You need to say M equals is going to be based on the height or the length, the span in this case, which is at 12 feet. It's going to be based on this pressure. Now it says here determine lateral pressure, soil lateral pressure or soil pressure, and the force demand. What is the force demand? The force demand here is going to be this force. So we're going to say the force in this case, we're going to say the force F is going to be equal to this 12 times 60 is going to be 720. If you like, you can divide by 1,000. You can do something like this. Times 12 divided by 2. Can someone help me? The reason that I'm dividing here by 2, or where is this equation coming from?
It's the triangle force. That's why you have base times height.
Okay. Yeah. So I'm going to assume here that everybody here is following me, and I'm going to be receiving questions on how to do the soil pressure, how to find out the force. So I have here two items: lateral soil pressure and force demand, service and factored. So what I have done here, it is all service. How do you do it factored? In this case, P sub U is going to be equal to 1.6 times 720. F sub U is going to be equal to whatever value that you have here multiplied by the load factor. And the load factor equals, you guys remember, 1.6. Where do I have this from? For H. Exactly, for the soil pressure H. Can I get to it? It's right here. You see this factor? Here's the load factor for soil pressure. So again, I'm gonna have here the soil pressure and the force. Soil pressure is gonna be P, force demand is gonna be F, and you have a very good example here how to do it for a cantilever system, right? So it's gonna be the same step that you're looking here at. Exactly same steps. The difference now is gonna be the moment. How would you find out this moment? Determine the moment on the retaining wall, service and factor, which means at one time, you're gonna consider, let me go back to it. At one time, you consider this soil pressure as is, like 720. Another time, you're gonna multiply by ultimate and find out the moment. So we're gonna have two moment values. One is gonna be for the service, and the other one is gonna be for the factor or ultimate. Determine the needed reinforcing. Now, how would you do here the needed reinforcing? Now, once you have the moment, and of course it's gonna be the factor, not the service, you're gonna use it to find out the moment. Do I have a good example on this? I'm gonna say yes, of course, absolutely. We have a very good example on this. It's right here. Let's give you the example. Once you get the moment, you just continue. same wall thickness, same depth that I ask you to use. You can just follow this, all of the steps here. After this, I'm asking you to check the reinforcing based on the moment demand, which means whatever reinforcing that you were able to use here in this item, the third item, you need to check it against the code minimum reinforcement for shear walls. Say for shear walls, I remember something about shear walls, minimum reinforcement. I'm gonna say, okay, here is a shear wall section. And it says the minimum shear reinforcement is how much? 0.0025 in both directions, vertical and horizontal. With that, you should be able to solve this submittal easily. Now, any questions on this submittal? Please ask me now. I'd like to get all the answers to you before you guys start to work on this. So I'm trying here to eliminate all questions. So it's gonna be so easy for you. You can just do it in a matter of maybe 15 minutes to 20 minutes, maybe half an hour max, if you like to read the whole thing from scratch. The good thing also, this lecture is recorded and I post them all online. So you can get back to it and you get back also the previous, right? And look at the minimum reinforcement, how it is used, and how would you use here the reinforcing like number 6 at 16 or whatever. How do you do all of that? You're gonna find it in all the previous lectures. Questions?
Is there a cover size?
I'm giving you here, I'm saying consider a depth of 9 inches. So would that tell you the cover size? Would that answer your question?
Oh, okay, thank you.
This answered the question, right?
Yes.
That's my vision. Okay, great. Good question. Thank you. Other questions? Any questions on determination of the soil pressure? How would you do it? Any question on this item here? How do you do the lateral soil pressure and the force demand? What is the difference between the soil pressure and the force? This give you some of the questions I'm expecting to hear. I'm gonna say, if you look here in this slide set, on the retaining walls, you say here's the difference. P is gonna be the pressure, and F is gonna be the force. So if you don't know the difference between pressure and the force, please go at the slide 15, slide set 18 on the retaining walls and look at this. This is gonna be the pressure and this is gonna be the force. Both of these two values here is at the service level. Why at the surface level? Because I just use the soil pressure given to me. It says here soil pressure usually is going to be given to you as in service. And then you need to multiply each one of them by 1.6 to get to the factor. Any questions on this step?
So when we're doing factored, we multiply 1.6 by the pressure, by the force, and by the moment.
By the pressure, by the force, by the moment.
Okay, all right.
So you need to take the service level, right? You just add the load factor, which is 1.6.
Okay.
All right. How about the moment?
Professor?
Yes, go ahead, please.
Oh, sorry. When we're checking for the reinforcement, do we check for both moments, like the service and factor?
Okay. When you do any design in reinforcement, in concrete design, any concrete design, remember this statement here. Any concrete design for a member to do the reinforcing or to check the shear, you're going to be using the factor or the ultimate moment in shear. You can't use the service.
Okay.
All right, let me repeat this again. Whenever you do shear design or check, whenever you do moment design or check, it has to be the ultimate or the factor forces and moments. You cannot use the service. The service is used for different reasons. For example, in foundation, what do we use the service for? We can say to size the footing itself. It is not to determine the amount of reinforcement and take the shear, any of that. No, you don't use here the service. Any questions on solving the moment? It is not going to be WL squared over 8. You cannot use this equation. There is another equation that I want you guys to look it up. Finding the reinforcing, I'm going to say you have a very good example. You just follow this example here. Check the minimum reinforcement, right? Whatever that you came up with here with, you need to check it against the code reinforcement. I'd like to hear questions from you guys.
Professor,
Yes.
for the force demand, can you explain again why do we divide by 2 again?
Good question, thank you. Look at this example here. The pressure at the bottom here, let's say 350, right? And the height in this example, a specific example, is 10 feet. How much is the area of this triangle for you? How do you do the area of a triangle shape?
1/2 the base times height.
Okay, so you take 350, the base, times the height, divide by 2. Exactly what we do. Good question, thank you. It's exactly what I'm doing here. I said here, the pressure at the base is going to be 6 times 12. It's going to be 720, right? Going to be taking this again. Now I'm trying to do here the force. I'm going to be taking the base pressure, multiplied by 12, the height, divided by 2.
Got it. Thank you.
No problem. Any questions on the submittal?
Would you mind going back to the statement?
Yeah.
You mentioned that the second point, determining in the moment on the retaining wall, that's what we learned in soil mechanics, correct? And that's what we're gonna use
This is
for
what
this
you
one?
learn in structural analysis.
Oh, okay, right.
Okay, structural analysis or statics, difference of materials, not in soil mechanics. This is like a structure thing.
All right. Okay, there we go.
Okay. All right. Now, once you're done with this submittal, are you guys there? Is everybody listening?
Yes.
Yes, please. I want you to be here with me, because now this is your last chance. I'm not gonna have more chances to say, okay, let's give it like 2-3 days and result. I don't have any of that. Time is running, right? So you're gonna be submitting everything that you have submitted before, but I'd like to see the correct version. Meaning, if you feel that you have done some mistakes in the past in your submittals, now this is gonna be the complete submittal. This makes sense?
So we're turning in all past submittals on December 6th.
Exactly.
Okay.
It's right there. See what it says. Next to this, it says upload all the submittals for the course project. All the submittals, not just one, not just number 7. No, I need the whole thing. And be sure that when I'm going to be looking at it, I know where is submittal 1, where is 2, where is 3. There should be some separation between all of these. So it can be one file, but you need to have like a cover page for each section, for each submittal.
Professor, so you'll be grading it based off the final one, right? So you said we can, like if we made mistakes in the previous ones, we can like apply the correction to the final version, right?
I'd like you to do the final version for grading and for discussion. However, the previous grades will also be considered. So I don't want someone who didn't, let's say, submit a 3 is going to come back to me and say, now I submitted 3.
Right.
So I cannot treat him the same way like others who submitted, let's say, submitted 3 and they did good job, right?
Okay.
All right. Now with that, we are done with the materials for this course. And this coming lecture for next week, I'd like all of you guys to join the same meeting, the same Zoom meeting for this lecture. And I'm gonna be going through. Give me a second. Let me just put the list. I'm gonna be having here a private meeting with each one of you guys. I'm gonna be going here with the list, with this order. So there's no appointment, but all of you are gonna be joining the meeting, and you're gonna be in the wait room. Gonna be meeting with each one separately. I'm gonna be discussing the midterm too. It's gonna be also a kind of couple of questions that I want to ask you to be sure that you know what you're doing. So it's gonna be a kind of an oral exam, if you like. Also, I'm gonna be here reviewing and give you a grade on your project.
Professor, you
Yes.
what date was that? You cut out on my
This is
end.
this is gonna be on Tuesday
Tuesday. Got
because
it.
your course is Tuesday and Thursday.
Okay.
So it's gonna
I
be
thought
the
I
same
heard
time
Sunday,
at 4
but
p.m.
Mhm.
No Sunday. So it's gonna be Tuesday and Thursday. You're gonna be joining the course or the lecture, right? And then you're gonna be sitting in the wait room. Just wait there. You're gonna be calling one by one to finish the review. All right. Any questions on that?
Professor, will we have like a review for like the final, or just will you tell us like what's the final?
Review of the final is coming now. It's gonna be coming in 5 minutes, but I want to be sure that everybody here heard me very well. So everybody knows that we're gonna have this meeting, right? It's gonna be a personal meeting for this coming week, right? During the lecture time.
Do we talk to you individually in office hours regarding whether or not we did our submittals correctly, like all our previous submittals? How do we know if we did it right or wrong?
We're gonna be discussing it, and I'm
Okay.
gonna show you exactly what you have done correctly and what is wrong.
Okay.
Is this cool? Good? Yes.
So it won't be on both Tuesday and Thursday.
It's gonna be
Right.
Tuesday and Thursday. Yes, this is absolutely correct. Agree?
Yes, sir.
All right, so we're clear on this.
Yes.
Very good. Now let's talk about the final. What are we gonna be seeing in the final, right? You guys see my screen?
Yeah, I see it.
Okay, very good. Now we discussed this problem, if you guys recall. With a beam like this, right? You remember this beam?
Yeah.
I guess if you look at this, you say here's the depth is gonna be, let's say 17.5. You have 3 number 7, and maybe also you have some top reinforcing, and also you have the flange. You remember the flange width? This is what you have done in midterm 1. If you recall midterm 1.
Yes.
Here's the one from midterm 1. This is the one that you guys have taken. And if you remember, I gave you on this problem, I give you 4 problems, right? We said at one time, we're going to be disregard the effect of the T flange and the effect of the compression reinforcement. That was the first problem. The second one, we said consider the concrete effect and disregard the effect of the compression reinforcement. The third one, we said forget about the T and just consider the compression reinforcement. You guys recall this problem?
Yeah.
You know where to find it or to find the solution in the slide set? Any questions on where to find it? Yes or no?
No.
So you have an access to the slide set. Excellent. Very good. So I need to give you something like this. At least, I mean, this section of the course, I cannot ignore it. All of the slides, I cannot ignore it. This is like the basic problem that you should expect in reinforced concrete design course. You need to know how to work with this. You need to do the compression reinforcement, which is the tension reinforcement. You need to do what else, right? You need to do the flange, compression flange, the cracking moment. So it's gonna be one problem on this. It's gonna be only one problem on this. Are you guys good?
Yeah.
Should I move
So-
to problem number 2? Any
so-
questions on number 1? Yeah. go ahead.
Yes. So there's going to be the one question is going to be about this. It's going to include everything from like exam 1 and up to now, correct?
One problem like this from exam 1. Yeah.
Yes.
It's gonna be something like this.
Okay. Thank you.
No problem.
Is it gonna include all 3 questions from the exam 1, or it could be any of the 3? Like,
Can be any of the 3.
okay. So it's not like, okay. Makes sense.
Yeah. All right. Any other questions on problem 1? No? You're good? Excellent. Now let's work here on problem number 2. I guess I'd like to work on the second midterm. I need to pick something from there, right? You guys recall this interaction diagram and you work on it enough. We did the column loads and then we did also the foundation. You remember this foundation problem?
Yes.
All right, very good. Also, do you remember this interaction diagram for round columns?
For the spiral, right?
Yeah, do you remember this? Have you seen it?
Yes.
Yes.
Okay, which slide set is this?
I can't recall, but I think it's maybe 8,
I
9,
think it's 11.
11.
It's right here. So we have used it, right? So you have axial load and you have moment. I'm gonna be asking you to work on this problem. So it's gonna be there. One problem in this interaction diagram. And if you recall, did we have a few of them? Okay, here we go. So you have 4 cases. I'm gonna pick one of these. Interaction diagram between an axial load and moment. So we need to work on something like this.
Professor, would you mind going
Yeah.
back to?
Yeah, absolutely.
So the difference between them was between like a moment and just a normal axial load, or?
This is axial load,
Mhm.
and this is a moment, not including the phi factor. Phi factor is not there. So be sure that you go through this example, right? This example is gonna be critical for you. You need to know how to do this. You see, it's short. See this, all of this? I mean, look at the amount of text or lines. This is very short. But either that you know how to do it, or you didn't study enough for it and you'll miss it.
Okay, thank you.
Any question on the problem number 2? Yes, no?
Nope.
Good. Don't you think we need to put something about the splice of a rebar? One small problem about the splice length? So here's 1/3 problem. This is gonna be a very small problem. I'm not gonna do this. This is gonna be too much, right? You cannot finish it during the exam. But I'm gonna give you the splice length. Here is the splice length. Where is the splice length? It's right here. This gave you 1.3 times LD. How do you do here the LD? You do it from the first light set, from the splicers, which is this one here. So what I want you to do is to do this example 5.1 and be ready that there can be a multiplier of 1.3. Okay?
Okay.
But when I do this, I'm gonna give you this problem here. If you remember this, it's gonna be on this. So you have your 3 number 5, I'm gonna give you here the cover, right? And the whole thing, and then you can do this problem. It's gonna be exactly like this. But it's gonna be on this given problem number 1, on this concrete section. And then you can do this. So be ready. You need, I mean, this is so simple. You can just go through it quick. It shouldn't be tough. How about the last problem?
Punching shear? Or no?
Well, how about foundation design and retaining wall?
Mhm.
That makes sense? So it's
Yep.
gonna be one of 2. All right? It's gonna be one of 2. So I want you to study for, let's say, 5 problems. We're gonna end up with 4 problems, okay? Retaining wall that you have just done. And you guys, you have it in your submittal. If you recall the submittal, right? You're gonna be doing reinforcing for it. Or it's gonna be punch and shear for foundation. One of the 2. Have we seen before punch and shear for foundation? I'm gonna say, yes, that was midterm too, correct? And we have a very good example on that. Which example is this? Let's go here. Here it is, slide set 12. Punch and shear example. It's right there. And you guys, you have done it already. Here's the example. Very short. See this? You see the amount of writing that you need to do? Like almost half a page to 1 page. 8.5 by 11 if you like. Let's say 1 page. So it's gonna be one of these punch and check or one of this retaining wall design. I guess we covered the entire subject, right? The entire course. So the problems actually I give you here is roughly like the entire course.
I have a question, Professor, for the formula sheet.
Yeah.
Are you gonna provide us
Yes.
the values for the development length, like what the value for epoxy is, like if it's 1.0?
Yeah, I'm gonna give you lots of information. Yes, you're gonna have all the information you need.
Okay.
Absolutely.
Thank
No
you.
worries about this.
Excuse me, is it going to be only retaining wall or shear wall or basement is going to be included too?
I said it's gonna be either punching check or retaining wall, one of the 2.
Okay, or retaining.
Yes.
Professor, can you confirm the time of our final?
The time for the exam is gonna be 2 hours.
Oh, I know, but like from 1 to 3 or?
The date.
Oh, you need the when it's gonna start.
Yeah.
How do you guys have it? Can you check?
I think it's at 5 p.m. until 6:50 on Tuesday.
Let me check for quick.
Yeah, that's what it says in the syllabus. 5 to 650. On
Yeah,
Tuesday.
I'm looking at the syllabus. It says from 5 to 650. So I'm
Yeah.
gonna make it here from 5 to 7. So I'm gonna give you 10 more minutes for scanning, not to continue working on the exam. All right? All right? Agree?
Yeah.
So once 650, you need to stop and start scanning. Any questions on the exam and what's gonna happen?
Is the
Also,
date on the 15th? Tuesday
Yeah.
the 15th. Okay.
yeah. Also, I want you to look at the following here. Would you please check the slide sets online in Canvas? Can you please go there quick and check it? See, what
Which
is the
one?
last one? Slide sets?
19.
When was the last one? 19? Do you have anything below this?
Oh, like exam 2.
Okay, can you open it, please? I want all of you guys to start to open it and look at it and tell me if this is truly the exam that you have taken, exam 2.
Yeah, it is.
Okay, very good. So here's what I want from every one of you guys. I want you to do your exam correctly over the weekend. It is not timed. You're gonna be sitting there, you're gonna be studying your exam, you're gonna be redo it again. And have it ready on you. Please do not email it to me. I'm not looking for you guys to email it to me. Have it ready for you for the review day, which is gonna be Tuesday and Thursday. Because I'd like to ask you about this exam. When I ask you about your performance in the exam and there's something wrong, I want you to be ready and say, here's a correction for it. And the main point of this is to give you a chance to study and to give you also a chance to give you a couple of points if needed. If you are not willing to do it, it's gonna be up to you. I'm not gonna have any good reason to give you more points. Does it make sense to everyone?
Yeah.
Yes, thank you.
Everyone, please. I'd
Yes.
like to
Yeah.
hear it from everyone.
Thank you.
Yes, thank you.
Thank you. If I don't have a solution from you for all the problems, like for the second time, not the first original solution, I'm not gonna have any good excuse to give you any more points. And I cannot discuss it with you. I'm gonna say, okay, you didn't do it correctly, so what? I'm not gonna say, now, can you do it correctly when we're discussing it, right? I'm not gonna ask this question. Either that you have it, and once we come to a point that you lost during your exam, if you don't have the correct answer for it, and if you don't understand it, I cannot give you an extra point during the oral exam. Just hoping that everybody's clear on what I'm saying here. I know that some people are not attending for the reason, but please, if you know anyone who's not attending, please let them know.
So just to be clear, we're not emailing this to you. We're just gonna have it ready for.
Yeah, have it ready, please. Do not send it to me in an email. Right.
Okay, thank you.
Anyone know Fah? Who knows Fah? Who's direct contact with him? Or Jamie? I'm not hearing anyone. Alexander, Omar, Diamond.
I
Amin.
might have some of their contacts.
Which one?
I
Which one do you know?
think Amin, but I'll try to let as
Amin.
many people know.
Please talk to him. Let him know exactly what we have discussed. It's not going to be easy to put it in an email. We have lots of information there. So Alexis, you'll take care of Amin. About Dylan, anyone knows him? Yes? No? Omar? Alexander? No?
I could take care of Omar and Amin. So.
Great. Okay, thank you. Now we have two people. Alexander, Jamie, and Fat. No one knows Fat?
I'll reach out to Jaime.
Amy, okay. Reach out to him. Very good. Who's this? Say it again, please. Who's that? Who just said he's going to be reaching out to Amy? Did you take it back or what?
I have his number. I can text him too, so you can have
Okay.
two people texting James or Jaime.
Okay, very good. Thank you, Nancy.
Professor, I don't know if this is just on my side, but for exam 2, I can see the cheat sheet, but I cannot open the questions themselves. It says the time, it says current score, which obviously is just not posted, and the attempt, but it doesn't show me the exam itself.
Can anyone help us with this? It depends when you're looking at. What are you looking at, right? You need to look at the lectures. Are you looking at the lectures?
Yeah, so I went under the exam section in home.
No, not under the exam. I'm saying the lectures. It's right here. You see
in
this?
the lectures.
Yeah, did
All right,
you see
all right.
this?
That makes sense. That makes sense.
Yeah,
Okay.
did you see this? Yeah, this is very good comment. Thank you, Anthony. Because I know that someone else may have the same issue. Do you guys see this here? All right, you're going to click on it. It's going to open this for you. Here's the exam. Any questions before?
For that exam, it's going to be unlimited time, and we can keep it open, right? If we close our computers, will we be able to open it up again?
You mean the final?
Yeah, for exam 2, the review.
For exam 2, actually, if you look at this, exam 2 is just a PDF. It is the same as all of these, so you can download it if you want to.
Let me see what's going on then. Thank you.
I thought that you're talking about the final there.
Professor, is it possible to post exam 1 as well? So that way we
Exam
can
1?
review. Yeah.
Yes, please.
Okay. All right.
Thank you.
Thank you.
Any questions? We're good.
Can I ask a question about submittal 7, please?
Yes, absolutely. Yeah.
So we actually calculated the P. P actually is going to be stress.
Yes.
But the maximum stress at the bottom part.
Yes, this is correct.
But how do we actually make it as a force? You know, because this is a triangular load, and if we want, okay, to find the maximum moment, so we have to have the force at that point.
Yes, you need to find out the force.
So,
but not to find the moment. You don't really need to have the force to find the moment.
So you mean we can do it from the flexural equation?
You can do it from this. Okay. When you have this stress here, you can find out the force, right? So here's the stress, here's the force. Now, how about the moment? If you have a cantilever system, which you don't have, it's going to be equal to this force times this height. But when you have uniform pressure, when simply supported, you're going to see an equation for it. It is something similar to W squared over 8, but it's not really over 8.
Okay.
You haven't seen this before at all?
Yes, yes.
When you have triangular distribution of force?
I have the formula. This is 0.128 WL. This is what I got from the steel manual. But the W there is actually is a force. So P here is a PSF. So I'm a little bit confused.
Which page of the steel manual, do you know?
It's going to be a section 3, table 323. Let me just give it to you. Page 3-208.
The steel manual, you have triangular distribution, right? This is what you're saying.
Yes. On 15th edition is going to be on page 3-208.
Here we go. Here it is.
Yes.
So the maximum moment for this pressure, and how much is this pressure? Do you know? What is the symbol used here for the pressure? It's going to be called W, correct?
Okay, so W is the same as that P.
Okay, hold on. Do you have here any definition for the term W? Look at this. Total equivalent uniform load. Total equivalent uniform load is going to be equal to this number times W times L. What does it tell you? What is W here for you? Is W the uniform load like P, or W is like the total force?
It should be total force, I think.
Yeah, because look at this. Look at this value here. And don't forget, when the uniform load is just there, you're going to say W squared divided by something, right? How about in this case? It's going to be WL cubed, isn't it? Or
Yeah.
just WL squared?
For here is actually going to be.
Look at this MX.
Here is WL.
Okay, why don't you look it up in the structural steel book? You can look it up in the structural steel book. You guys, you need to do some work in this one.
Okay.
I want you guys to spend some time, find out the moment based on this. And another way of doing it, just look for this location. Try to find out the moment at maybe 6% of the span. Go there at 0.577, right? Find out this amount of pressure right here and take the section right here at this place. You're gonna have one force coming this way at 1/3 of this distance, and you have the reaction coming up. You're gonna be taking the reaction times this distance, subtracting this force, right? Which is equal to the integration of this triangular shape multiplied by 1/3 of it, of this distance here. And now you can confirm the meaning of this W. Because look at this. Look at definition here. Look at this. It says R1 equals to V1, which is W over 3, which means 1/3 of the reaction is going to be going left, 2/3 is going to be coming right, which means W is the total load. W is not the uniform load, right?
Yes.
Okay, very good. Any other questions on the exam, on the submittal?
Professor, could you explain real quick the building code problem with the slide?
Building code
For the
problem.
submittal,
With
the
which one?
last part where it says
Absolutely. Yes. Okay. All right. Absolutely. Give me a second. Let me get that. Here's submittal, and then you're talking about code minimum reinforcement for shear walls.
Yeah.
You're talking about shear walls, right? So I need to open the shear wall slide set. Here's the shear wall slide set, right? Nice pictures. And then it says here, the minimum vertical or horizontal steel ratio in the reinforced concrete shear wall is equal to 0.0025. Meaning, what I need to do here after I'm done with the reinforcement, and let me throw here some numbers. Let's just say that I was able to get it as with number 5, let's say at 12 inches. All right, let's give you the amount of reinforcement. The code minimum value, it says 0.0025. Let's give you like the steel ratio, right? So what is the steel ratio for number 5 at 12? This is gonna be the limit. So I'm gonna say this is gonna be the limit, right? It's gonna be this guy here. The limit is 0.0025. So how about for number 5 at 12? This is what I have provided in item number 3. I'd like to check it against this. So I'm gonna say number 5 is how much? What is AB for number 5? Can someone help me with this? Yes?
0.31.
Square inches. What is the spacing? So I'm gonna say what is AS for this number 5 at 12 inches? I'm gonna say AS for number 5 at 12 inch equals the amount of reinforcement that you put there, 0.31 multiplied by the wall thickness, which just happened to be also 12 inch, divided by the spacing. It means I'm gonna have here 0.31 square inch per foot. This is just the AS, okay? Amount of reinforcement. I'm gonna say, how about the steel ratio? I'm gonna say steel ratio is gonna be equal to the amount of AS that I have provided, divided by the wall thickness, divided by a strip, which is equal to 12 inches. Can someone help me with this value? Yes? Guys?
0.31.
0.0021?
Yeah.
Yes.
Is this good?
Yeah.
Good or bad?
Professor, sorry, can you explain this value 0.0021?
This is the steel ratio. This is AS divided by area of concrete. Here's the wall. Can I have only one rebar here? This is what I'm thinking, right? This is what I'd like to do. Can I have a rebar at 12 inch? We're good? So it's gonna be all the way to the end. This wall thickness is 12 inches here, right? You agree with me or no? Or I'm missing something?
This 12 inches, is this the length going
This is
into
the
and out
thickness
of the
of the wall.
page?
Yeah, no. This is here, the thickness, this width here, the thickness of the wall. I'm looking here at the top to the wall. This is like
Oh.
plan view.
Yeah, okay.
I'm gonna have this gonna be like the vertical rebars, right? And the spacing between each two rebars, according to what I'm saying here, just my assumption, is gonna be 12 inch. So also from one rebar to the other rebar, it's gonna be 12 inches, right? Okay, yes? All right. So I'm gonna say the spacing is 12 inch. So what I'd like to do, I'm gonna be taking this section from here to there. And this is what I'm gonna call here the strip. The strip of the wall is the width of it is gonna be 12 inches. It just happened that the spacing is 12 inch, which is the same as the width of the strip. So I'm gonna say this is one here, I'm gonna call the strip width. And this one here, I'm gonna be calling it the wall thickness. Wall thickness is 12 inches. How did you do here the steer ratio? You do the steer ratio, which is this one, is gonna be equal to AS, area of the steel, divided by area of the concrete around it. So we're gonna say steer ratio is area of steel divided by area of concrete.
Isn't there supposed to be a multiplication between the 12 times 12 for the area?
Yeah, that's why I'm dividing here by 12, divided again by 12, which is the same as if you do this. If you like to do it this way, you get the exactly same answer, right?
Yes.
All right. So I'm gonna say the total area of steel per foot, based on this analysis here, is gonna be 0.31. Total area of concrete is gonna be 12 by 12. So here's the steer ratio. This is not good. Why? Because it's lower than 0.0025. Where did you get this 0.0025? From here, right? It was given here in the slide set. So we're gonna say this is not good. So you could either reduce the spacing, like what? You can say options. Make the spacing smaller. Like I'm gonna be going here to 8 inch. I say, okay, you can make it 8 inch if you want to. But you're gonna be missing a very important point. That once the wall is gonna be thicker than 10 inches, you need to have 2 layers of steel. What does it mean by that? It means I need to have another layer of steel, vertical steel right here. I need to have some reinforcing here, right? Code says once you go here above 10 inch for the wall thickness, you need to provide another layer of steel. Has anyone seen this before? Or this is something new to you guys? I'm gonna say it is mentioned here. Look at this. For walls with H greater than 10 inch, except basement walls and cantilever retaining walls, distributed reinforcement is given 2 layers. So you can say, well, I have here 2 options, right? Option number 1, I'm gonna say here, option number 1, add another layer of reinforcing. Option number 2, reduce the rebar spacing.
Professor, we do this because in this case, the steel ratio
Is low.
was not
Yes.
exceeding the 0.0025.
Yes, because it needs to go beyond this.
Oh, yeah.
All right. Once I go here to 12 inch, I'd like to go with another layer of reinforcing. So I'm gonna say this is gonna be my best guess. I'm gonna say go for this. Tell you the reason. This wall also, it works as a concrete shear wall. This is the reason that we have this statement there. And once you have a shear wall, you'd like to see here 2 layers of reinforcing. So definitely I'm gonna be going with another layer of reinforcing. This layer, the space is gonna be up to you. You can keep it at 12 inch. And if you do this, in this case, AS is gonna be double of this, double the amount. Why? Because you don't have just 1 rebar, you're gonna have 2 rebars. Someone else can say, well, I can provide this reinforcing just 1 rebar at 24 inch. Look at this. So I'm gonna be saying option 1. I'm gonna be going here with option 1. What do you wanna do? I'm gonna be adding number 5 at 24 inch. How much is this AS? I'm gonna say AS equals Now it's going to be equal to the top value, which is the 0.31. You remember this? I need to add it. It's still there. Plus number 5.31 divided by 24, or I'm going to say times 12, divided by 24. So this term that I just added this term here is going to be for this rebar. This term is going to be for this added rebar at 24 inch. Now, how much is the total? Is it 0.46? Yes?
Yes.
Okay. Inch square per foot. Say, great. Let me do the steer ratio again. I'm going to say the steer ratio in this case equals 0.46 divided by 12 times 12. How much is that? Yes? Help.
0.0032.
Is this higher than 0.0025? So, okay, good, I'm done.
Professor, I thought the maximum spacing for rebar was at 18 inches. Can you do 24 for this because it's like supplemental rebar?
Exactly, yes, because I have the main reinforcing and I don't really need this.
Okay, thank you.
Very good point, thank you. Yes. Yes. Someone else is going to say, how about option 2? How would you do here option 2? I don't like this option and I want to just do one layer. It's going to say option 2. How would you do option 2? Option 2. You're going to say, let's just make the spacing to be 10 inches. Now AS equals, I need help here. 0.31 times what?
12 over 10.
How much is this?
.372.
Now the steer ratio, how much?
.0026.
This is good?
Yes.
Okay, so it's gonna be up to you. You do it the way you want. Just do one option. Don't show me two options in your solution, right? Just pick one and go with it. I'm not sure if number 5 at 12 is gonna be able to resist this moment or not, right? Also, I'm gonna change this. I'm gonna give you a chance to use number 5 or number 6, just in case. How about that? So you can use number 5 or number 6 is only. Let me change it now before I forget. So you can choose. Any other questions? Or we're good? You wanna leave or stay with me?
I'm good.
All right, guys, go ahead, sign out, and Good luck.
Thank you, Professor.
Thank you, Professor.
Thank you. Thank you.
Thank you. Have a good rest of your night.
All right. You too. Good night.
Professor, do basement walls normally like carry some of the weight of the building?
Yeah, they are also exposed to vertical load and to shear and to moment. This is why I'd rather maybe go with 2 layers, right? And usually we go with minimum numbers, number 5 at 16, because give you the minimum. And in many cases, we add more reinforcing to it. Yeah. Carlos?